Right, find the gradient of the graph y is equal to a third x to the sixth power minus a half x to the fourth power and 1 over 6 at the point 3, 50. We know that f of x is this same graph. And we know our gradient, f dash x, when we differentiate this, to have which simplifies to give us 2x to the fifth minus 2x cubed. So that's our derivative of f. Now we need to find the gradient at that point. Now the point 350 of the graph y is equal to f of x corresponds to x equal to 3. So this is a question that is simply asking to find the gradient of the graph at the point x, or just at x equal to 3. So at x equal to 3, the gradient is the derivative of f at 3. Which is 432. And that's it. Just another way of asking for you to find a gradient of a graph or a function at a value x equal to 3. Thanks for watching this video. My name is Alistair. I'll see you on the next one. Bye for now. At what time does the piece of wood have a velocity of 21 meters per second? We know when v is equal to 21, then we have 21 is equal to 14t. Bear in mind we did calculate our velocity function as v is equal to 14t. And our solution here, t, is 21 over 14, which gives us 1.5 seconds. So hence, the piece of wood has velocity of 21 meters per second. Let me just write this clearly here. So t is equal to 21 over 14, which is equal to 1.5 seconds. And to summarize, the piece of wood has velocity of 21 meters per second after 1.5 seconds. Thanks for watching this video. My name is Alistair, and I'll see you on the next one. Bye for now. Hello. Find the gradient at the point negative 2, 2 of the tangent to the curve x cubed add x squared y add y cubed equal to 0. For this, we'll use implicit differentiation. So we have 3x squared. Remember, this is a product, x squared y, so we'll use the product rule. I'll put this in brackets so you can see what its result is. It's 2xy. If you'd like to know a bit more about the product rule, just have a look at my A-level and you'll see a playlist, so you'll see examples of it. And this is x squared dy dx. And now we differentiate y cubed to get 3y squared dy dx equals 0. Now when x is -2 and y is 2, we have that this expression here, or this equation, now becomes 3 -2 squared add 2 xy, add x squared, which is -2 squared dy dx, add 3 y squared dy dx equal to 0. Now when we evaluate this, we have 12 minus 8 add 4 dy dx, add 12 dy dx equal to 0, which gives us that dy dx is equal to minus a quarter. And there you have it. Very useful application of implicit differentiation. A lot easier than finding, rearranging to find for y and then differentiating y. We just differentiate implicitly. Always remember to identify what your terms are. Here we have a product, which means we use the product rule. Enclosed here in brackets is the result. Thanks for watching. My name is Alistair. Bye. Hello. How do we differentiate y is equal to brackets 3x add 7 raised to the half, or the square root of 3x add 7? Well, this is a function of a function. We have the function, the square root, acting on something which is a function of x in brackets. So first, the rule is to differentiate the outer, so that function, the square root function, and multiply by the derivative of the inner. This is a fairly straightforward one, but I urge you to get started by assigning variables like this. So let's u equal what's in the brackets, which is 3x add 7. So if we find the du dx here, will be equal to 3. And if we have that this is u, then y we can rewrite as u raised to the half. And if we differentiate this function dy du, that's equal to a half u to the minus a half. Now, we need to find what dy dx is of this function we're given. And we can write it dy dx is equal to dy du times du dx. And we can write that as dy du is this part here, a half. We'll bring this into the denominator, so this becomes u, the square root of u, and this is times du dx, which is just 3. And we write this as 3 over 2 root, and we can substitute now for u, which is 3x add 7. Differentiate the outer and then multiply that by the derivative of the inner. Here again we have a function of a function. We'll let u equal to what's in the bracket, x squared minus 4, and we have y now equal to u raised to the 5th power. So du dx, we're differentiating this, is equal to 2x, and dy du 5u raised to the 4th power. So dy dx is equal to dy du times du dx. dy du is 5u raised to the 4th power, and we're multiplying this by 2x. Now we can substitute for u, and we have, let's do this first, 5x squared minus 4, and we times 2x, that becomes 10x brackets x squared minus 4. Oops, I forgot my power of 4. Function of the function of a function rule. Differentiate the outer and multiply by the derivative of the inner function. Thanks for watching. My name is Alistair. Hi, you might be familiar with differentiating a product of two factors. Well, what about if you have y is equal to u v w? Well, you can write that as y is equal to u v times w. So we have a product of 2 times w, and our derivative looks like this: v w du dx and wu dv dx and uv dw dx. So let's say we have y is equal to x minus 1, 2x add 1, and 3x add 2. So d dx, or d of dy dx, which is here, we'll put it all together as x minus 1. So we're just showing the differentiation of all of y here in the first line. 2x add 1, 3x add 2. And now we go ahead to differentiate v vw du dx and so on. So first d dx of x minus 1, and that's times 2. Let me just write this. And that's times 2x add 1, 3x add 2, added to d of 2x add 1, dx of this, and this is times x minus 1, 3x add 2, and this is added to d dx of 3x add 2 x minus 1 and 2x add 1. This evaluates to the first here, evaluates to 6x squared add 7x add 2, 6x squared minus 2x minus 4 added to 6x squared minus 3x minus 3, giving us a simplified version, which is 18x squared add 2x minus 5. And there you have it. You just need to be careful with your algebra. But to do it, so if you look at more than two terms, applying the product rule, in this case we use for 3 factors, and this can be extended to any number of factors. Thanks for watching this video. My name is Alistair. Bye for now. Hi, how do we determine the equation of the tangent to y is equal to 3x squared minus 2x with gradient 2? Well, we're told that the gradient is 2, that's the value of the gradient. Now we can go ahead and find the gradient function of the curve 3x squared minus 2x. And that we'll do by differentiating f of x, which is 3x squared minus 2x, to get 6x minus 2. And we're told also that the gradient is 2, its value is 2, so we can equate 6x minus 2 to the value 2, which gives us 6x is equal to 4, so x is 4 over 6, which is 2 over 3. Now we can go ahead and find our y coordinates. So y is equal to 3. We'll substitute for x into this equation of the curve. 2 over 3 squared minus 2 times 2 over 3. And this gives us 3 times 4 over 9 minus 4 over 3, which is 0. So now we can go ahead and find the equation of the tangent. So these are our coordinates, and we'll use the formula y minus y1 is equal to m into x minus x1 to find the equation of the tangent to this curve. So we have y at 0 and x at 2 over 3, So this is y minus 0 is equal to, and the gradient is 2x minus 2 over 3. And this works out to be y is equal to 2x minus 4 over 3. And this gives us the gradient, the equation of the tangent to the curve with gradient 2. Thanks for watching this video. Keep practicing, and practicing some more. Bye for now.